This is Christian Jules Lab 8. I'm going to plug the USB cable in. It'll be running this program that's already up there, including the serial monitor. And down here, I have my board, which also has the R2R DAC on it, and here's my servo motor. When I turn the potentiometer, it goes 180 degrees, and the serial monitor reflects that as well. I have it printing the duty, which I've written as a function of the potentiometer value. It's not optimal, there's some chatter, but I'm not sure what the reason is for that. This is my table for the expected voltage given the different 3-bit bit codes. I use this equation here. V full scale voltage times the code divided by 8, which is 2 to the third power. Full scale voltage is 5 volts. And I solve for the least significant bit voltage up there by dividing the full scale voltage by 2 to the bit value, and it's 0.625. This is my Circuit Lab R to 2R 3-bit DAC. As you can see here, I have 3 bits, 3 different things, and when I simulate it with all the switches open, the voltage at the node is 0 volts. And when I close the third switch, which would give a value of 4, I get 2.5 volts, which is expected. I simulated all the other values and got what I expected as far as output voltage at that node. This is my 3-bit R to 2R DAC. Those 3 red wires going to power and ground. Those are my quote-unquote switches. Right now they're ground power, which would give a code of, in 3-bit it'd be 4. And so up here I have my simple code that will just print the pot value to the serial monitor. And oh yeah, the output from this is just going into one of the analog pins there. And so we're getting 534 when we do the math on that. Given that that's a 10-bit value, we get 2.607 volts, which is a little higher than the expected 2.5. When we switch the middle switch to power, that gives us a value of 6. The potentiometer value is around 827, or sorry, not potentiometer, but the 10-bit value that's coming into the Arduino is 827, which corresponds to 4.038 volts, which is also a little bit higher than 3.75. As I said, these values are a little high. I'm not sure why that is. And if I wanted smaller step sizes in the DAC, I would add more combinations of resistors, adding effectively more bits. So here's my exercise 2, and all I did was I recycled the code for the potentiometer, and I basically just took the input from the R to 2R DAC and plugged it into the input I specified in the potentiometer code because they're both going to be 10-bit values. So it's currently running right now, and if I change these, it will put the, so for example, right now they're all off. If I go to 1 being on, it rotates it a little bit. That's a value of 1. If I go to value of 2, rotates it a little bit more. Value of 3, a little bit more. Value of 7, far more. It works well. Again, if I wanted a smaller step size, I would just add more resistors in there to make it effectively a 4 or a 5-bit, or however many bits I wanted of a DAC.